So hi guys, welcome back to my YouTube channel. Today I'm up with the next question of the top 150 interview questions of the lead code. Remove duplicates from sorted array, second version. So we are given an integer array nums sorted in non-decreasing order. Basically it's ascending order. Just to confuse it, non-decreasing order. Remove some duplicates in place such that each unique element appears at most twice. So the main point is each unique element appears at most twice. That's what we have to consider. The relative order of the element should be kept same. Since it's impossible to change the length of array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements, after removing the duplicates, then the first k elements of nums should hold the final result. It doesn't matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with of one extra memory. So let's get started with the question. So we are given an integer array nums, as you can already see. We are having triple ones, double two, single three, double four, triple five, and we have to return the output double one, double two, single three, double four, double five. And not only we have to do this in place, but we have to return the length of this output, that is our 9 elements. So let's just deep dive into the thought process of this question. In the previous video, I've already discussed the first version of this question. So let's discuss this. Let's just try to apply the same and try to solve a question. So let's take 2 pointers k and I which will traverse through the whole array, and k which will keep the unique elements. So let's get started. So for the 0th element, as we know, there are no two previous elements existing before. So this is the first unique element and the first occurrence of this unique element. Simply we will increment our I and k. So now talking about the element 1 at index 1. Since the previous element is equal to 1 and there is no second previous like the second one, which is there is no element at -1th index, because -1th index in an array does not exist. So basically this one is the second copy of first unique element in the array. So we will not do anything, we will simply increment our I and k. So talking about the element at second index, which is 1. So the previous two elements, that is 1 and 1, are equal to this one. So it means already we have two elements in place. So we are not required. So basically we don't require this element. We'll simply remove it. We'll simply ignore this and increment our I as it is and leave our k at that point. So comparing 2 with the previous two elements 1 and 1, both of them are not equal to 2. So we will simply replace. So we'll simply copy our 2 at kth index, that is over here. And now what we have is 3 2's in this array at this point. We'll simply increment our k and or I. So talking about this 2, so both of these 2's are equal to 2. So we will not touch it, like we will ignore this 2 and increment our I. Talking about 3, so 3 is not equal to both of its previous. So we will simply copy 3 to index number 2. That is the index which holds the position k. So we will simply copy our 3 over here. So we are having a single 2 and we are having a single 3. So what has happened? We have actually lost 1 2 in this case. So basically, with this approach, we are losing one of our elements. That's what the problem in this approach lies. So what to do in what is the solution of this? So we have to do something or the other. So let's just think about it. So let's redraw the array again and think about the same. Let me copy the same array as it is. 111, 22, 3, 4, and then we are having 3 5s. So as per the question, how many copies of a unique element are allowed in the array? Maximum 2. So we can have at max 2 copies, 2 elements, 2 copies of a unique element in our array. That's what the thing is. So why not we keep the count of each element in this case? Like the count of 1s 3, count of 2s is 2, and count of 3s being 1, and count of 4s being 2, and count of 5s being 3. I think this approach will help us solve a problem, because at this point, the moment our count reaches 3, greater than 2, so we can simply ignore that element, right? But when I talk about taking count as taking the count of all the elements, so something like nested loop comes in our mind, right? So we need to take a nested loop. But yeah, and in that case, some of you might have got a thought in your mind that the time complexity of this problem will reach to O of n square, whereas this is the point. So some of you have thought that time complexity will reach to O of n square because we are using nested loops, right? But that's not the case. Our time complexity will remain O of n. Why so? Because suppose we are having a test case like this, like we have all ones in our array. All ones in our array, right? So as per the question, we are only required to keep the first 2 ones. So what is the count of these ones? It's equal to 5, right? So what is 5 of this array? 5 is the size of this array. Size of this array is equal to 5 and count of the array is equal to 5. So at max, till what point our count, so at max, what is the range of count in our array? It would be from 1 till, so at max the range of the count in our array will be equal to 1 till size. So our count will lie between 1 till the size of the array. So that's why the complexity of this problem will tend to be O of n, not more than that, will be of n actually. So let me erase all of this thing and let's discuss that part. So okay, let me just maximize my screen as well so that it's much clearer. So as we are doing in the last approach, like we are taking a pointer k, we are taking a pointer I, and now we will, instead of I, both of these, we will take an additional thing. We will take an additional variable count which will hold the frequency of the unique element, that is the number of times that element is occurring in the array, right? So let's get started with the approach. So let me take our k, our I, and the count. So since we are at, so let's start our loop from the 0th index. We have encountered an element, so we will keep on. So we will take a while loop in which we will count the frequency of elements of this array, and we have got the frequency as 3. So according to the question, as we know, the maximum allowed frequency is 2. So we will compare this 2 with the count, and the minimum of it will be our answer, right? So the minimum of this element, suppose this minimum is tends to be x. So we will keep our 1 at the positions. So we will keep our ones according to this minimum count x. So we will place our 1 at those positions. So let's start with it. So our k is at 0th index, I is at 0th index, and talking about 1 is equal to I plus 1, right? And I plus 1 is also equal to 1. So our count will equal to 3. So we have got our count as 3. So minimum of 2 and 3 would be 2. So we will copy our elements at these k positions, right? So we'll copy our element element 1 at nums of k, which is nums of 0, is equal to nums of I, and then so we will copy our nums of I at these many k positions, right? So basically, at how many positions we have to keep a unique element and how many times we have to keep is all solely determined by k, as in the previous approach, right? I think it had got a little bit fast, so I'll repeat it again. So what we are doing, basically we took a pointer I which will traverse through the whole array, and we took a pointer k which will basically, in this we are basically storing those elements whose count, in which we are storing all the unique elements with the maximum allowed frequency of 2. So k will store all the elements, all the unique elements which are present in this nums array with the maximum frequency of 2, right? So that's what our question is. So what we have done, we have simply took the count of all the elements which are equal to it. So why we took count and why it's easy for us to take the count, because our array is already sorted, so all the equal elements will exist adjacently in the array, right? So that's why we took count easily. So whenever we get the count, we'll compare it with 2, the minimum amongst them. So whenever we get that minimum, we'll keep our element I at those minimum positions. So suppose let's just try run it, and afterwards we will clarify why I took the minimum amongst them, why not only 2. So right, so I think everyone can see that answer, but let's wait for a while and then we will move further. So I got my answer as 2. So I'll keep my element I at those many k positions, right? So I'll keep my 1 over here. Let me just copy it somewhere else. So I'll keep my 1 at this point and also at this point. I'll increment my k over here and I'll increment my I. My I will reach at 2. So my I has reached over here and my k is present at this index, right? So I'll compare my 2 and this 2 and my count. So I'll compare my 2 and 2. So I'll get my count for 2 as 2. Okay, so I'll compare it with this function minimum count and 2. So I'll get my count as 2. So what I will do, I'll simply copy this 2 at this position. Okay, and I'll simply copy this 2 at this position, and while I'll be copying this, I'll be simply incrementing my k, and now I'll reach at this position, which is, so my this position becomes empty for other element to come, for other element which is unique, since I've already copied all the frequencies of 2 before, right? So moving on to 3. So let's compare 3 with the other elements of the array which are after 3. So since there is no element after 3, so we will simply copy our 3 at this position and move our k further. So our k comes over here, so we can simply keep this space for other elements. So let's move on to 4. Comparing our 4 with 4, we get a count of 2. Comparing it with this minimum, we get the count of 2, and simply we will copy our 4 to both of these indices, and we get a 4 and 4. And then we will increment our k, and our k reaches over here. So taking the count of 5, 5, 5, 5, count comes out to be 3. Pass it in this minimum function. Minimum of 2 comma 3 is 2. So copy these 2 5s in this k, and so after copying, our array will look something like this, and then we will increment our k. So after incrementing our k at this point, we will basically get the length of the element which is having all the unique elements, and with the maximum of 2 copies of that unique element in the array. Basically, if our element is 1, we have 2 ones at max in this array. That's what we are doing in this question. So let's just code this problem right now. Let me move to my other screen. Let me just remove this code. So that's fine. Let's take a variable n, which is equal to nums.size. Let's take a variable I, which is equal to 0, which will actually loop through the whole array. And one thing I forgot to mention in the previous discussion is that the space complexity will remain O of 1, because we are basically modifying our input array nums under k0, which will keep the track of all the elements that we have to return. So ultimately we will return our k, right? So while our I is less than n, so we will simply keep a variable count which is equal to 1, because whenever we are at ith position, we always have one element by default. By default, what is happening, by default we are having one element whose count is always 1. So frequency of this element is always 1. That's why I took count as 1. So let's loop through the code. So while my nums of I is equal nums of I plus 1, I'll compare it, and then I'll keep on incrementing my count. But wait, in this case our I can sometimes go out of bound, so we have to keep a track on I plus 1th index must always be less than the size of the array, and in this way we'll increment our I as well. So we got a count. So I'll take a variable x in which I will store the minimum of the minimum of count, comma 2. So the minimum amongst them will 1. So I'll take one loop j, which will actually place all my elements in those k positions. So I'll copy my nums of k with nums of I, and I'll simply increment my k, and then I need to increment my I as well at this point. Why am I incrementing my I? Because after this comparison, if I talk about so after this comparison, my I will stop for a while, but comparing this element again and again will not make any difference. So basically for this element we have got all the frequencies right in the count, so the work of this element has already been done. So our I is still pointing to here. So to reduce this work, so to move further, I have incremented my I. That's it. So let's just submit our code, run our code. Good. So let's submit it. So I think our solution is an accepted solution with 0 millisecond. Wow, that's nice. So I hope guys that you have liked this video. If you have liked this, if you liked the way I explained the question, do like and subscribe my channel, and please do share it with your friends as well. And if you feel that I have missed out something, please do mention it in the comment section. And if you want to take any other guideline, this is for freshers, related to the placement or what to do, how to make a study plan, you can refer to the links in the description below. You can either connect with me on LinkedIn or on Topmate or on Preplease. So thank you guys, and bye bye. Keep watching my videos.